Hey guys, this is Patrick from STH. You might be sitting there and wondering, why is Patrick behind 100 hard drives or 1.2 petabytes of storage? And the reason for that is today we are doing the Dell PowerEdge XE7100 review. Now, Dell launched the PowerEdge XE7100 back in 2020, and they said, hey, Patrick, do you guys want to go review one of them? And I said, yes, not really thinking about what I was getting us into. What we actually have is a 100 hard drive, a 3.5-inch hard drive system. You can put some SSDs in there as well, but that's not just the whole of it. Now, when Dell launched the PowerEdge XE7100, I frankly didn't really see the point. I thought it wasn't a really awesome system, but I was completely wrong. And the reason I was wrong, I think, is because Dell's marketing is absolutely horrible. The engineers that created the XE7100 are, I think, absolutely phenomenal. They did an absolutely great job with this box that the marketing department is just totally fumbling. During the initial release, and something that Dell EMC likes to tout is the fact that they are saying this is like the highest density server. It has 100 3.5-inch drives. And that certainly makes it a very dense solution. And we're going to talk about what some of the implications of that are. But at the same time, yeah, there are definitely 4U chassis that go well over 100 drives. Apple's been using those for years, and a whole bunch of other large companies have been using it for years. So this is not necessarily anything, 100 in a 5U system is not necessarily like anything groundbreaking from a density standpoint, but that totally misses the point. The vast majority of those 4U, 90 to 114-ish drive bay systems, those tend to basically have a single controller node. Really nothing to be really too excited about. But what the Dell PowerEdge engineers actually did was they created a very flexible solution that uses some parts that we've kind of seen before. Now, I'm recording this at 4 a.m. before I've had any coffee because this is a topic that makes me absolutely upset. These engineers that built this system, I think, did a phenomenal job. Not only can you have one or two dual socket servers in the platform, but you can also have things like GPUs. You can have big GPUs, you can have small GPUs, and they even have an option where you can add a card with 20 M.2 SSDs. And while you might think that that's the SSD option, there are 8 slots on our system that you can actually put SSDs in without even using any of the 100 drive bays. So in this review, we're going to do what Dell's marketing clearly is incapable of doing. And I'm going to explain to you why this is not just some kind of boring 100 drive system, but this thing is insanely cool that the engineers did an absolutely great job of, and they need to get some recognition for it. So let's get into it. So let's start with the chassis overall. And something that you're going to notice is that this thing is just absolutely huge. Just to kind of give you an idea, this was a 410-pound pallet that arrived to be able to deliver just this system. I thought that there was some other system in it, and no, it's not. So with any of these systems, one of the big concerns is things like weight and also dimensions. Now, one of the nice things about this server is just the fact that it is not overly deep. Now, some of the other 100 plus drive 4U systems, they have to go fit in that node. And because they have to fit in nodes and expanders and all that kind of stuff in 4U, they tend to extend a lot further, which means that you need larger racks. And one of the challenges of having a longer node to be able to fit all of that kind of functionality in just 4U is that sometimes when you go and fully configure racks and you get them shipped from the factory, the rack posts have to be a little bit further to accommodate the larger servers. And what has actually happened quite a bit, like this was actually a big thing in the industry for a while, was that the servers and the storage servers would actually bow, and then you'd have to RMA the server because it would break during shipping. So by making a shorter chassis that's 5U, it actually kind of works out for Dell. The really cool thing about having the shorter 5U chassis is the fact that you can put it into an existing rack. You don't need those larger racks. Now, the big innovation that Dell is using in this chassis is that they basically have 1U of space on the bottom of the chassis, which is really for all of the server bits. We're just going to call them server bits, but that's everything that's basically not drives, power supplies, or the primary fans. And that leaves the top portion of the chassis for just basically the bare essentials, which is 100 hard drives, but then also power and cooling. There's pretty much nothing else up there. Okay, so let's start with the top of the chassis because that's where all of these end up going. And then we'll get to the bottom part, which I think is actually kind of the big differentiator. The way that you open up the 5E chassis is basically there are two portions of a lid that you can open. You can either open the front side, the back side, or you can just take the entire thing off. I think most of you can imagine how you take a piece of metal and undo latches and pull it off. So we just kind of have that off so you can see without all of that going on. This is a very, very large and very heavy chassis. So it wasn't one that we could necessarily move around like some of these smaller servers that we have. In our test configuration, we have a bunch of Dell firmwared Seagate Exos X16 drives, but they're the 12 terabyte models. The system itself can support either SATA or SAS drives. There are options to put some SSDs in this chassis, but the basic idea is that you're going to put 100 hard drives. The drives themselves don't just drop into the chassis bare. Instead, there are little carriers. These are actually toolless models, so I think that that's really nice. I mean, honestly, this would be 400 screws to go and screw in. Like, who wants to go and spend their life doing that? That's like torture to go do. So I'm really happy just at the fact that Dell is using toolless drive trays here. I think that's really nice. Even with these drives in their respective trays already, this system took a long time to put together. The hard drives themselves arrived in boxes of 25 hard drives. So I had 4 boxes with 25 hard drives each. Now they're all in ESD bags and they're already in their little drive trays, but it still means that you have to undo the box. You have to go and pull the drives out of their ESD bags. You probably plop them on something and then you have to go put them into the chassis. And if all went well, we're probably watching a time lapse of me going and actually installing 100 hard drives into this chassis. You can tell a couple things. So first off, you're going to be able to see, even though it's going to be pretty fast, that the process was actually a pretty long one. I also definitely have ADHD, and so I had to go and find a way to occupy myself by not just putting them in linearly, but putting them all over, trying to balance it. I don't know. I just wanted to do something to kind of keep my mind occupied because it took a long time. You're also going to see that I struggled on a couple of them, and the reason that I struggled was frankly just the fact that this is on a little turntable, so that way I can actually reorient the thing because it weighs, hundreds of pounds when it's all put together. And I had it on this, and I think that meant that the chassis flexed a little bit, and because of that chassis flex, I think they didn't go in some of the corners just the way you'd like to see. Just to kind of illustrate how far off it was, which is actually pretty far off, I went and I just kind of popped all of the little latches and I saw which ones popped all the way out and which ones of the latches actually didn't pop out and just kind of stayed in. And this kind of view is what that is. I will say that when I did it in the data center on a hard table, it did go a lot better than this, but there were still a couple of them that didn't latch perfectly. The other thing that I want to note is that you definitely want to have a server lift if you're going to go install this thing. You want the one that supports the system from the bottom, not the one that is going to pull on the top, because the top will pop off most likely just given the weight of this thing. Overall, something that I was a little bit surprised about just with such a large chassis was the fact that it didn't look like there was a ton of very visible types of vibration dampening. For example, some of the hard drive manufacturers, when they do their big JBODs or something like that, they'll end up having things like PCB will be cut out to give a little bit of vibration cushion for all these. So the connector PCB is actually cut out. And I didn't really see any of that here, but Dell has a pretty nice design otherwise. Something that we're not going to do is be able to go do 5 years of testing with this thing under load to go see how many drives fail. Just frankly, I don't have any interest in doing that. But that is why you have a Dell warranty on your drives. And having a warranty on a system like this, well, there are kind of like two trains of thought, right? So a system like this has 100 hard drives. And if you think of a hard drive failure rate as, 1% or whatever it is, 2%, 3%, whatever a year, even if it's 0.5%, there's a good chance that if you have a couple of these, that each of them are going to get serviced maybe once a year, if not a little bit more. And if that happens, well, you're sending somebody into the data center. Now, if you're at a large organization and you have, like a hyperscaler or a very large enterprise, what you have is you literally have people that will just walk down the aisles every week or something like that and just go and plop new drives into whatever system is missing a drive or has a failed drive, and they'll just go and do that real fast. That's a philosophical debate whether it's better to have a Dell service technician come in and do that, or if it's better to go and just pay your own employee to go do that, especially if you have a lot of these. Something that Dell does have in terms of management for these and in terms of their overall Open Managed suite is they do take the telemetry data of all of these drives. They can see if there's something that's looking like, this looks like based on our data set that this is going to fail soon. And so we can start doing things like doing advanced replacements and stuff like that. So that way you don't actually have a drive fail. You can plan for it, mark the drive as failed we let the array heal, and then go and put a new drive in once it arrives. Something that you will notice that is somewhat common in this class of systems is that you have front fans that will actually push air through the entire chassis, and that's not how this works. Instead, there are just 6 large fans that sit in the back of the chassis that are very easy to hot swap. I mean, Dell engineers did an absolutely phenomenal job with it. But there are basically only 3 fan modules in this entire chassis to cool the 100 hard drives. The other thing that you're going to see on the top part of this chassis is you're going to see 2 power supplies. These are 2.4 kilowatt units, which, well, you kind of need. Each of these hard drives uses 5 or so watts at idle. And when you are at, I think, their max power consumption somewhere around 10-ish watts, or something like that, or typical is around 10 watts when they're in operation. Just this, you have to plan for at least 1 kilowatt of power consumption just for that. So let's get to the bottom of the system, and let's start with the front because that's kind of the easy one, or kind of maybe more of the fun one. On the front of the system, you're going to notice that we have 2 modules, and these 2 modules, each of them has 4 SSD bays. Now this is of course very configurable in terms of what you want in all of these, but if you use small SSDs, you can put 4 SSDs there. Really good for something like having boot drives and maybe a cache drive or something like that. That's what that's there for. Also, these modules have 2 other features. We notice that there is a PERC card in these as well as also a expander. Now, of course, in a 100 drive system, you're not going to have a direct connection to all of the drives. You're going to use expanders. And the reason that you do that is just to, I guess, make it more efficient. But then the other thing that Dell gets out of this design is that it makes it easier to integrate different types of systems and topologies into this chassis. For example, we could have a single node or we could have dual controller nodes. Now at this point, you're probably thinking, oh my gosh, this is actually kind of a cool system. But then you get to the rear of the system and you figure out where the real magic happens. Specifically, Dell has different compute options that you can have in the system, and we had 3 of them to take a look at. So our server is set up with 2 nodes, and that's really just the way that it came. And so that's the way we took all of the photos and we took some of the B-roll with, but there are other options as well. We're going to talk about those 2 nodes real quick. And if you look at the nodes themselves, you're going to notice that they are definitely designed for this chassis, but you may also notice they look something, well, kind of like something that we've seen before. Specifically, these are the 2U 4-node half-width motherboards that we see in some of Dell's other PowerEdge designs. So the really cool thing here is that Dell is definitely looking at, okay, well, this is kind of the motherboard that we have. Can we just use that and put it in a system that makes sense? And they did a really awesome job, I think, with that here. You might remember that we did the PowerEdge C6525 video and review, and you might think to yourself, well, hey, is this EPYC? And this is not. This is Xeon Scalable. But if you look at how many DIMMs they have on either side, there's 4 DIMMs on either side, so 8 DIMMs per CPU, 2 CPUs, and that gives you a total of 2 CPUs and 16 DIMMs in this chassis. There are some limitations though. Since you do have a 1U system and you have all the heat from the hard drive and all the cooling and all that kind of stuff, you're limited to, I think, 150 watt TDP Xeon Scalable CPUs. Frankly, that's my best guess on why we don't see EPYC in this particular chassis. It just, well, kind of seems like EPYC tends to have higher TDPs, and maybe that's why we don't see it. Otherwise, I have to say, I definitely would have rather have seen an EPYC-based system. Just the fact that you get more I/O, you can have PCIe Gen 4, which lets you just do more with all the PCIe slots that you have. I think that would have been definitely an upgrade, but of course, Ice Lake is around the corner. Now, of course, whenever you have 2 nodes in a system like this, the first thing you're going to think is like, oh, is that a active, or a high availability cluster? And well, it's not really. It's actually what happens is that you get 2 hemispheres and you basically get half of the drives, so 50 drives for one controller and 50 drives for the other controller. If you have a single controller node, then basically all 100 drives go to that one. But let's just assume, for example, that you just said, hey, I don't need to have a second node in here. At my Ceph cluster, I want 100 drives per node, not 50 and 50. So what would you do then? And one of the really cool things that you can do, and one of the, I think, big differentiators of the system, is the fact that Dell has various options that you can use that second node slot for. The first one that we're going to look at is you can have a double width GPU, or I guess other accelerator, but this particular one is using an NVIDIA Tesla V100 GPU. And you can see that this chassis basically has a way to go and guide airflow from the front of the chassis to the GPU and make sure that it stays cool. And that's the higher end GPU solution, but there's another solution where you could have up to 4 low power, low profile single slot GPUs. In our particular example, we have the Tesla T4, now the NVIDIA T4, and you can see that we have 4 of them, and that allows you to have a whole bunch of different GPU options or a range of GPU or accelerator options in this chassis. Now you might be wondering, why would I even want a GPU in a storage node like this? And it actually makes a lot of sense. Let's take a really good example of like video analytics, which is a huge area. I mean, there are cameras absolutely everywhere and people want to start doing analytics on the video that they're collecting. So instead of a model where you make a query to your storage pulls the video from disk and then pushes it over the network to a GPU server, and that GPU server goes and does the analytics and then maybe does something with that data after, pushes back to the storage server or whatever. Instead of having to do that, instead what you can do is you can just go query the server directly. The local GPUs can go and run analytics, and that lowers the burden on your network, and it's just a more efficient way to go do it because you're not moving bits as far. There is one other really cool option that I have been trying to find the Dell part numbers and trying to see if I could just go order one. Dell has something called the DSS FE1. I think that's what it's called. If not, we'll have a little note up on the corner. But what the FE1 basically does is it's a PCIe by 16 riser that has a switch chip, so PCIe switch chip on it. And then there are little risers that go on that by 16 card. And in those little risers, what you basically get is you get the ability to put M.2 SSDs. And so I think that entire setup is good for up to 20 SSDs. I looked up the pricing on that thing, and the list pricing is somewhere in like the well over $10,000, $12,000. And I think some of the configurations are like over $25,000. I just kind of want the assembly to go and be able to buy. So if anybody knows what that part number is, let me know. I just want the card and the risers. I think that would be just super awesome to have. But while you are still limited to the by 16 uplink, getting 20 SSDs into a little form factor like that, I mean, you could have 20 SSDs plus the SSDs up front, plus you could have 100 hard drives. And I mean, what kind of crazy storage system could you build with something like that? If you want to know why I get absolutely upset at the fact that I went and sat through all the pre-briefings and stuff on the XE7100 and I was totally not impressed by anything, but then I actually get the system like, oh my gosh, this is way better than Dell's marketing is saying it is. I think this is really the reason. They're able to go and fit something that's in a short depth. I mean, it's not the highest density. Stop saying it's the highest density, Dell. It's the highest density that fits in a kind of standard-ish rack, but it's also 5U, so it's not the same density as a 4U system. I'm just get off that, right? Like let's just kind of call it what it is. It is a very dense system, but by having that 5U form factor, we don't get stuck with some kind of lower end compute. We get a whole bunch of compute and storage and all kinds of accelerator options that we wouldn't normally get in a 4U system. Now, in terms of performance, we had a 25 gig network NIC in this. And so of course, with 100 spindles, you're able to saturate 25 gig Ethernet. I mean, of course you are, but I'm gonna be totally frank with you. These systems that you see here are not designed to be one system that we're testing in a lab. Instead, they're designed to be multiple systems in something like a Ceph cluster, some other kind of cluster, or some other kind of scale out storage solution. And so really the way that we would test it for that would, well, not be really right. But of course we created a giant ZFS pool because, well, we had 1.2 petabytes of storage. Of course we were going to, and you probably would too. Now, Dell did a really good job in terms of cooling. So in terms of CPU, GPU performance, we saw basically what we saw in other servers with this one. So we basically would say that this is a good job of cooling those components. Power-wise, if I were going to budget for a system like this, what I would say is budget at least 1.5 to 2 kilowatts. You're going to need at least that, and there are definitely options to go higher. So I would say that those 2.4 kilowatt redundant power supplies are definitely needed. I mean, well, like, let's face it, with 100 hard drives that can hit 10 watts each, that's 1 kilowatt right there, and then you have CPUs, GPUs, all kinds of stuff. So I would definitely budget a ample amount of power for these. But on the other hand, they're 5U, so really the power density is not super high. Now, the one piece of advice that I would give you is to 100% go check your racks before you put a server like this in here. Now, at 5U and, given the weights and stuff, it's actually not too bad, but I would just double check, because what you don't want to do is say like, oh, I can go and put 8 of these in my rack. I have enough power, and then find out that you don't have the structural rigidity in your rack to be able to handle so much load, or maybe your data center floor or anything like that. So just make sure that you can handle this loading, because what is a really bad case cases, you could get these all racked up and then all of a sudden you find out that your racks are warping or your floor is warping or something like that. That would be a really, really bad situation. So just avoid it, double check before you install something like this. Now, overall, this is not the densest system out there, and you can definitely go and create architectures where you have, something like JBODs or something like that that can hit higher densities than something that Dell is doing with this. They know that. Everybody in the industry knows that. But what this is a really good option for the Dell ecosystem. So if you're a Dell customer and you want a server solution that is one of these high density servers that fits your rack and has a whole bunch of different flexibility. So if somebody in your organization says, hey, we need to go do a video analytics project or some kind of other data analytics project, you can totally do that in the system. And that's really what Dell designed. They didn't try cramming the most hard drives per U that has ever been done. They're not even close to that. But what they did do is create something that works really well in the Dell ecosystem. From a business perspective, this is a super important system for Dell. And the reason for it is actually kind of interesting. The marketing folks will tell you that this is important because they have a better box than the HPE folks do. But that's kind of the wrong comparison point, which is the other reason I was totally scratching my head at the initial marketing presentation. Now, these large storage servers are designed for companies that have large amounts of data. And a lot of those really early companies that had a ton of data were the same ones that were going out to Whitebox and ODMs to go and get lower cost servers so they can use open source or their own proprietary storage solutions. Let's be clear, the purpose of the XE7100 from a Dell strategy perspective is not to go and take customers. Like if somebody's an HPE customer, they're not going to become a Dell customer because of the 7100. What it will do, and what the Dell engineers did a phenomenal job of doing, is creating a box that is definitely good enough and is so good that really there's not going to be that same reason to go and look elsewhere outside of the Dell ecosystem to fit those needs. Overall, I think the product teams and engineers at Dell did a phenomenal job with this system. As I was going through it, you could definitely tell that the fit and finish were very good for a system of this type, and I think they did just a phenomenal job, so they definitely deserve recognition. Great job, guys. And hey, I hope you enjoyed this video. You probably saw this week we did a 32-port 400 gig Ethernet switch. We were the first site to go do Cooper Lake, the 4-socket server platform from Intel. And then we now did a 1.2 petabyte system that also has GPUs in it. Next, get ready for Milan. And hey, if you made it this far and liked this video, why don't you give us a like, click subscribe, turn on those notifications so you can see whenever we come out with great new videos, including that Milan one. As always, thanks for watching and have an awesome day.